Hello, this is me, Uzair Shaukat, and in this video, we're going to talk about biodegradable polymers. So before getting familiar with the term biodegradable polymers, we need to know what are natural polymers. So as the name suggests, polymers produced naturally are called natural polymers. So we do have proteins, we do have starch and cellulose, we do have DNAs as the natural polymers. So proteins have monomer unit as amino acid, starch and cellulose have monomer unit as glucose, and DNA have monomer unit as nucleic acids. So all natural polymers are biodegradable because nature contains all the enzymes to degrade them. So natural polymers are biodegradable. All natural polymers are biodegradable because nature itself contains the enzymes to degrade them. And what are those enzymes called? Those enzymes are called biocatalysts and are naturally present in soil, water, and all living organisms. And yeah, we do have some synthetic polymers that are that also get degraded by the biocatalysts, that is enzymes. So what's the most common example is nylon to nylon 6. Remember, it's not nylon 66 because I get mostly confused with it. So nylon to nylon 6 is made up of two monomers that are glycine and amino carboic acid, and we get nylon to nylon 6 as polymer after the polymerization. So in this nylon to nylon 6, we do have a peptide linkage, that is CO and NH, that can be hydrolyzed by same enzymes that degrade a protein. Therefore, it can be degraded by biocatalysts. And remember, this nylon to nylon 6 is synthetic. And another example we do have is PHBV, that is this, okay? So it's made up of two monomers, that is 3-hydroxybutanoic acid and 3-hydroxypentanoic acid, and we get PHBV, which contains ester bond. So ester bond is a natural bond, and therefore, it can be degraded by the natural biocatalysts or enzymes. So that can be hydrolyzed by living organisms. So another. And then we do have the polylactic acid. Polylactic acid is degradable but not biodegradable. You need to remember that. So as in the previous slides, we have written at the top, only some synthetic polymers are biodegradable. What's the reason? So it's because only if synthetic polymers have same chemical linkage as that of natural polymer. For example, if they have ester bonding, amide bonding, or glycosidic bond, they will be degraded by the enzymes. So therefore, only some synthetic polymers are degraded because they contain these bonds. And then if we summary, we do have these biodegradable polymers, we do have natural and synthetic, as already said. And next, now we do have the applications, we do have potential. These polymers have potential to replace all the available polymers. They are highly useful in many industries, and they are also lightweight, and they when those polymers degrade, they degrade into non-toxic substances which can be easily removed, which is non-toxic to nature and environment. Okay. So in food packaging industry, disposable, we have PLA, a polymer which is widely used in food packaging industry because of its non-toxic nature. And then we do have the medical applications, of course, slow release of medicines and in hygiene products. So there is a polymer that is very useful in drug, that acts as a drug carrier. That is, it carries the drug in our body to a specific target position, and then drops its payload, and then degrades into the non-toxic substances that can be easily removed from our body by the process of metabolization. So these are some of the applications. Thank you. Have a nice day.